Hello and welcome to the third video in a series on measurement and math for science. In this video we'll be looking at a way of both converting among units and for solving problems called the factor label method or dimensional analysis. In dimensional analysis or the factor label method, we are making use of known relationships in order to find unknown relationships. Now, if you do an internet search for unit conversions, you'll turn up thousands of different tables that look like this that tell you relationships among different units of lengths, different units of mass, different units of temperature, and so forth. In fact, every single test that you take this year and while you're doing lab work, you will have access to a conversion table that looks like this. What I'm going to show you through using factor label method and dimensional analysis is how to use these factors in order to solve problems. So if we look right here, the very first conversion factor is 1 kilometer equals 0.6137 miles. That's a conversion factor. Another conversion factor that you might know off the top of your head is that there are 12 inches in 1 foot. 12 inches in 1 foot is a conversion factor. If I were to ask you how many inches are there in 2 feet, most of you could probably do that in your head because for each 1 foot there are 12 inches, and that would make for 24 inches in 2 feet. And so we've just solved a factor label or dimensional analysis problem in our head by doing this. The problem is that we very quickly run into problems where we can't do it in our head, and we need to have a systematic method for converting from one number of a unit to another number of a different unit. And that's what we call the factor label method or dimensional analysis. In the general format for dimensional analysis, we have a number that we've been given, and that number has a unit on it. And the general form is that we write the number. Let's say this is the 2 feet that we used in our example problem, 2 feet. The 2 is the given number, feet is the unit, and what we do is we take whatever unit is on the number and we carry that down to here, being careful not to take the number down but just the unit. And now this box or this multiplication factor represents a known factor. Now you might know that off the top of your head, or you might have to look on the list, but if we're converting 2 feet, we bring the unit feet down into this box and we ask ourselves, what do we know that will get us to inches? Because we were trying to convert 2 feet into inches. And so I know a conversion factor off the top of my head, and I bet you do too, between feet and inches. And so this number up here is not related to this box down here, but certainly the unit of feet comes down here. And in this box we're going to put the relationship among feet and inches. And there are 12 inches in 1 foot. And now the units of feet cancel out algebraically, and we are left with the unit of inches on top. Well, that's what we did in our head, right? We took 2 times 12 and we got 24 inches. And that's the answer to this problem. As the problems get a little more complex, we will continue with more factors coming out to the right, perhaps, than just one. But certainly just having one factor is okay as long as that allows us to solve the problem. If we have a number that has both a unit on top and on bottom, we treat the top and the bottom separately. So the method will be the same. If we have to convert this unit into something else, that unit comes down here and we go up with a conversion factor that is either off of a chart or out of our head. And when we get ready to convert this unit on the bottom, that unit has to come from the bottom up to the top, and we go down with an appropriate conversion factor. So let's just go ahead and draw this. We got unit on the given number in the top. This could be miles per hour. So miles is on top. We bring the unit miles down here, and we convert that to a different unit, let's say A. And now units U cancel, and we're left with unit A on top. And if we wanted to convert the bottom, V, we bring that up to the top, and we go down with a conversion unit, which cancels out the V. And now we're left with units of A over B. So when we set a problem like this up, the numbers that go here and here are how many A's are there and how many U's. And this number that goes here and here are how many V's are there in how many B's. So these conversions here and here are either things that you know off the top of your head, like 12 inches equals 1 foot, or 5,280 feet equals 1 mile, or 100 centimeters equals 1 meter. Just in general, these guys have to equal each other, both top and bottom. So now let's do a few problems. We have 5 miles equals how many centimeters? Now, I don't think you're going to find a conversion from miles directly to centimeters. But that's okay. I'm going to use the conversions that I know off the top of my head. And the conversions I know are that 1 mile equals 5,280 feet. That's a conversion factor I know in my head. And I know that there are 3.28 meters, 3.28 feet in 1 meter. And the final conversion factor that I know off the top of my head is that there are 100 centimeters in 1 meter. And certainly there's no expectation for you to know these conversion factors. That's why we have the chart. That's why you'll be able to use a chart like this to be able to find these factors for the remainder of the year. So I'm going to follow the format. I'm going to put what is given in the top left box, 5 miles. And the pattern is I take the unit in the first box and bring it down and then go up with a known conversion. So I'm going to take the unit mile and put it in the bottom box. And my conversion that I know from miles to something to get me closer to centimeters is to feet. So I'm going to put feet in the top. And now this becomes a conversion factor. There are 5,280 feet in 1 mile. I'm going to draw another line. And I'm going to bring, now that I know that miles has canceled, I'm going to bring the unit feet down here. And I know that there are 3.28 feet in 1 meter. So I'm going to convert in 1 meter, there are 3.28 feet. And I'm not done yet. I don't have my units in centimeters yet, so I'm going to bring this unit down to the bottom, meters to centimeters. And now I'm going to do a conversion. I know that there are 100 centimeters in 1 meter. Okay, and now unit feet has canceled, unit meters have canceled, and I'm left with a unit of centimeters that did not cancel out. Now on my calculator, this is multiplication and division. Order of operations is not important, so I could take 5 and multiply that by everything on top and then divide by everything on the bottom. I can ignore the ones. And so on my calculator, the way that I would do this is 5 times 5,280 divided by 3.28 times 100. And that will give me my answer of how many centimeters are there in 5 miles. Let's go down one. Look at another example where we have a top and a bottom. And so this 6.9 grams per centimeter cubed, we're going to have to convert into kilograms per meter cubed. And so I've got 6.9, and I want to put grams on top and the unit centimeters cubed on the bottom. I'm going to convert the top part first. I want to go from grams to kilograms. The conversion I know there are that there are 1,000 grams in 1 kilogram. There again, I know that off the top of my head. The other conversion factor we're going to need to make use of is that there are 1 million centimeters cubed in 1 meter cubed. So 10 to the 6th centimeters cubed equals 1 meter cubed. This is 1 million centimeters cubed equals 1 meter cubed. Okay, so I start with the top, bring grams down, go to kilograms using that conversion factor. I know that there are 1,000 grams in 1 kilogram. I've converted grams into kilograms. If we stopped the problem here and took 6.9 divided by 1,000, I would be in units of kilograms per centimeter cubed. However, I'm not finished. I want the bottom to be meters cubed. So I take centimeters cubed, which is on the bottom, and I'm going to cancel that out by placing it on the top. And now I can use my conversion factor that 1 meter cubed equals 10 to the 6th centimeters cubed. 1 meter cubed equals 10 to the 6th centimeters cubed. Centimeters cubed cancels, and I am left in units of kilograms per meter cubed. On my calculator, I'm going to ignore the ones, and I'm going to take 6.9 times 10 to the 6th divided by 1,000. And you might be able to do that in your head. One more example of a common conversion that we need to do in physics is if we have 55 miles over hours. Now notice this says miles per hour. We only understand that to be the case here in the United States. We understand that that's a mile. The abbreviation for mile is really MI because M is just a meter. I'm going to do this rather quickly here. I'm going to go from miles to feet because I know that conversion. I'm going to go from feet to meters, and I know that in 1 mile there are 5,280 feet. I know that there are 3.28 feet in 1 meter. Now I've canceled out the units of miles, I've canceled out the unit of feet, and I'm left in meters per hour. I don't want to be in meters per hour, I want to be in meters per second. So I'm going to bring the unit hours up to the top, and if I'm really careful, I can know that the number of seconds in 1 hour are 3,600 seconds. That's 60 times 60 in 1 hour. And now I have canceled hours, and I am left with units of meters per second. Here again on my calculator, I'm going to ignore the ones, and I'm going to take 55 times 5,280 divided by 3.28 divided by 3,600 equals, and that will give me the number of meters per second in 55 miles per hour. I would like to point out that a common practice method of using dimensional analysis is to use a nonsense system of measurement. And here we have a given number of factors that really don't make any sense to us. 1 gleam equals 27 blops, 1 blop equals 34 riddigs, whatever, this goes on and on. But the point here is that if you know the factors, you can apply this. So this says how many gleams are in 1 riddig. So I'm going to start and put 1 riddig on top. That's what's given. I'm going to bring the unit riddig down to the bottom. And what can I do here? How many gleams are in 1 riddig? So if I go here, I know that this one involves a riddig. There are 34 riddigs in 1 blop, and there are 27 blops in 1 gleam. And that's what I'm looking for. I'm looking for gleams, so I'm going to convert from riddigs to blops. And I know that right here there are 34 riddigs in 1 blop, and then I want to bring the unit blop down, and I know that there are 27 blops in 1 gleam, and in 1 gleam there are 27 blops. So now even though this is a nonsensical measurement system, we have the factors that we were given up here. We have the thing that we were given in the problem. How many Rittigs, in one Rittig, how many gleams are there? So the unit Rittig cancels, the unit Blop cancels, and I'm left with units of gleam. Now in order to find the number of gleams, I'm going to ignore the ones, and I'm going to say 1 divided by 34 divided by 27 equals, and that will give me the number of gleams. Once again, if this system doesn't make sense to you or you need more help, I'm perfectly willing to give that help in class. All you have to do is ask for help, and we can talk about any or all of this process. Thank you, and good luck.